Hello, everyone, and welcome to Dr. Anum AI. I am Dr. Anum, a PhD scholar and computer science specialist. On this channel, we decode the complex world of artificial intelligence and explore how technology is reshaping our future. Let's dive into today's video. For decades, computer science education functioned like an assembly line. Students sat in dimly lit rooms, isolated behind monitors, memorizing rigid commands of machine language. Success required recalling hundreds of specific commands and typing them out character by character. We taught coding as pure manual labor, where a student had to master syntax before they were allowed to solve an actual problem. This structure creates a massive administrative burden. This chart breaks down how a typical coding teacher actually spends their day. Finding a missing semicolon in 40 different assignments consumes the bulk of their time, leaving almost no room for mentorship. The consequence for students is a heavy investment in mechanical drills. They spend semesters mastering routine tasks that modern software now executes in seconds. By focusing so heavily on these manual skills, our education system trains graduates for a job market that is rapidly disappearing. Then, large language models emerged. The machines learned to interpret human intent, and the old mechanical bottlenecks began to break. The definition of computer science is moving away from manual construction. It is becoming a discipline of human AI collaboration. Instead of hunting for typos in 1,000 lines of Python, a developer now describes the logic in plain language, reviews the generated code, and refines the result. Those who learn to direct these models can scale their output significantly. Those who stick to manual entry risk being outpaced by basic automation. Sticking to a syllabus built entirely on manual syntax means students leave school with a skill set that is already being outpaced by software. When a school integrates these tools, the mechanical burden on the educator begins to lift. Teachers are using assistants to generate highly specific lesson plans. They enter a curriculum standard, and the AI provides a structured module ready for the classroom. This diagram shows how an AI handles a complex topic like machine learning fusion. The system takes a dense, intimidating concept and organizes it into three separate nodes for the teacher to present. During a lab, the AI acts as a first filter. It catches a student's missing bracket or logic error in real time, explaining the mistake to them before the teacher even needs to intervene. Look at the time allocation chart now. As the hours spent on manual grading disappear, the capacity for student mentorship expands to fill the entire day. The algorithm doesn't replace the teacher, it removes the drudgery of marking code, allowing the educator to return to the role of a human mentor. For the student, the experience changes from a static lecture to having a patient companion available for every line of code. In a room of 30 people, 30 different learning speeds are happening at once. The AI tracks each student's progress and adjusts its feedback to match their specific pace. When a student struggles with a complex algorithm, the AI breaks it down into digestible pieces using analogies tailored to that student's existing knowledge. This removes the psychological barrier of asking for help. A student can ask for 20 different explanations without feeling embarrassed or slowing down the rest of the class. With the fear of failure minimized, students experiment more freely. The classroom becomes a space for true one-to-one mentorship. This approach prepares students for the reality of the modern workforce. This illustrates prompt engineering leverage. A single instruction triggers an entire network of code. The real value is directing that intelligence. A syntax-only worker is limited. The worker who curates the most ethical, efficient path possesses real market leverage. Mastering computer science is no longer about learning to speak like a machine. It is about learning to lead the systems that write the code. The 2030 job market will move at a pace that manual methods simply cannot match. The students who master human AI collaboration today will become the directors and architects of their industries. Those who continue to rely solely on manual coding will find their skills increasingly devalued by the accelerating pace of innovation.
Integrating AI into education clears the administrative path for teachers and ensures students enter the workforce as directors. It equips them for a century defined by this part.
I hope you found this video insightful. If you are passionate about AI, healthcare technology, and professional research, make sure to subscribe to Dr. Anum AI and hit the bell icon for more expert insights. Feel free to drop your questions in the comments below. See you in the next one. Stay curious.